Welcome to the lecture series of Fourier transform. In this video I will discuss about the inverse Fourier transform of function in the process of partial fraction expansion. In this way, first of all, you need to determine the partial fraction of a given function. So if we think that we need to determine the inverse Fourier transform of that function, the denominator would be transformed in the multiplication format like that. And as we know, the process of partial fraction is it has some general approaches. I will discuss in at the end of this video. I will provide the table by which you can easily formulate where should you write a, b, or some variable. So as we have seen that here the root is -2, the root is -4. So after solving this, we can get the value of a is equal to 1, b is equal to 5. How can we solve this? We already know the method, but I want to remember you how could we solve this. So this portion, for this portion we could multiply by using j omega plus 2. Actually that part, by multiplying this part from both sides, actually we will get an equation, and where we just need to put j omega is equal -2 for any to support a root. In that case you will get the value of a, and the another case when you put j omega is equal -4, then you will get the value of b. So in that case a would be 1, b is equal 4, 5. And if you don't have, if you feel any problem or have any query regarding that, please ask me on WhatsApp, or you can ask during the class session. So or it's very simple to you. I think I hope it would be easier for you, and you perform it in several times. So what would be our next step? Actually we know the Fourier transform, this Fourier transform property. If you need to transform e to the power -80 ut, our Fourier transform would be 1 divided by a plus j omega t. In this case, actually we have this fashion. We need to transform from frequency domain to time domain. So this portion can be inverse Fourier transform. This would be also inversely transformed. So what would be our time domain? What would be the xt? Because this is in the frequency domain, so xt would be inverse Fourier transform of that plus inverse Fourier transform of that. If we compare this and that, we can simply write the inverse Fourier transform e to the power -2t ut, and for this case it would be 5 e to the power -4t ut. So basically in this video I will discuss how should we partially fractionize the term we are given, and then we actually how to perform the Fourier transformation. So if we think about another function as like that, so how could we solve this? Actually we in the similar fashion we need to determine the value of a and b, and in this way by multiplying both sides we can get this equation, and by equating real and imaginary part, we easily can get the value of a and b. So putting the value of a and b, we simply have the we will have the equation as like that, and for the similar fashion as we discussed earlier, the Fourier transform of e to the power a -80 ut is given by 1 divided by a j omega. So here we can transform that part, and we also know the Fourier transform of t e to the power minus 3t as like that. So in this way we can actually be able to transform inverse Fourier transform in the way of partial fraction. The most important thing when you will be asked to transform using partial fraction, you must need to convert in this way, as we have done like that. So first of all, you need to formulate this fashion, A B C fashion, depending on the numerator and denominator. If the numerator and denominator is like that, you should expand like that. The function should be expanded like that. For this fashion, this would be the expansion. For this function, this pattern should be followed, this pattern, and for this case in this pattern. And after that, you need to multiply the denominator of the left side, multiply the both side by the denominator of left side, as like that. And after equating the real and imaginary part, ultimately you will get the value of A and B. So this was the procedure. In that case also I did not discuss, however this procedure can be followed for this case. So the first thing, you need to perform the expansion depending on the given function, as in these 4 steps actually I tried to present here, which you need to follow. After that, you need to multiplying both sides by the denominator of left side of the equation like that. After separating the real and imaginary part, you will get the constant value of constant, and after placing that you will get actually the convenient shape or convenient function whose transformation or inverse transformation is known to you. Then you can transform. So after all, you will get the inverse Fourier transform of a given function. So this is the procedure. Actually, I hope it would be very helpful for you, and I request you to practice more this sort of example. Thanks for watching.